Let's move on to the next question, that is question number 4, a question from determinant. It says if this determinant is equal to a plus b plus c into x plus a plus b plus c whole square, x is not equal to 0, a plus b plus c not equal to 0, then x equals. If you remember, this is a well known question also available in your NCERT. When you see it, you can apply certain operations, it will end up as a plus b plus c whole cube. It is given x is not 0, so obviously x can be taken as negative of 2 times a plus b plus c, and that would be the result if you remember. Or you can apply certain operations like R1 replaced with R1 plus R2 plus R3. Benefit, you can see a plus b plus c coming in the first row and that can be taken common. So that gives us a plus b plus c multiplied with 1, 2b, 2c, 1, b minus c minus a, 2c, and then you have 1, 2b, c minus a minus b. Correct? This is the left hand side. Now, if I apply C2 replaced with C2 minus C1 and C3 replaced with C3 minus C1 with the objective of making these two elements 0. So, it gives us a plus b plus c multiplied with 1, 2b, 2c, 0. Now, this becomes b minus c minus a minus 2b, that is minus of a plus b plus c. Then you have 0, 0, 0, and this becomes minus of a plus b plus c. Now, on expanding, simply you can see the product of diagonal elements multiplied with this factor will be the result. So, it comes out to be a plus b plus c whole cube. Now, this is given to me a plus b plus c multiplied with x plus a plus b plus c. X is non-zero also mentioned. Since x is non-zero, that means x should be negative of 2 times a plus b plus c. So that you can see this was whole square here. So that when you put this value here, you can see it becomes minus of a plus b plus c whole square, making it positive. So the result is simply fourth option from the given options. Let's mark and mention as the correct answer. Let's move on to the next question, that is question number 5. Let a function f from 0 to infinity to 0 to infinity both open be defined by fx equals 1 minus 1 by x, then f is. Now, question has a problem, and what is that? When you look at the function fx equals 1 minus 1 by x, clearly x equals 1 is the part of domain, it is there, correct? X equals 1 lies in domain. Since x equals 1 lies in domain of f, right? But when you go for the value of the function at 1, you observe 0, which is not there in codomain, which is not in codomain. That means this is not a function. So, it clearly means this is not a function from 0 to infinity to 0 to infinity. So, just mark here, therefore, f is not a function. Yes, if you include 0, then it will become a function, but such thing is not allowed, as it is clearly given in the paper f 0 to infinity to 0 to infinity open ended. That means this question is not correct. Let's move on to the next question, that is question number 6. If integral this is fx into root of 2x minus 1 plus c, then you have to talk about the function fx. Simple question from indefinite. We need to integrate this function, right? So, for integration what we need to put 2x minus 1 as t square, that is 2 dx becomes 2t dt, or simply we can say dx is equal to t dt. Therefore, let us say this is I is equal to, we have x plus 1, x is t square plus 1 upon 2. So, right here t square plus 1 upon 2 plus 1 divided by t into t dt. So that's the integral we are looking for. This is equal to 1 by 2 times t is cancelled. We are left with t square plus 3 inside. So integrating, we have t cube by 3 plus 3t plus constant of integration. We can take t common and we can write it as t is actually root of 2x minus 1. So let's take t common. We are left with t square by 3 plus 3. So right here 2x minus 1 by 3 plus 3 inside. Correct. We can take LCM of this term to make it root 2x minus 1 multiplied with 2x minus 1 plus 9, that is 2x plus 8. 2 taken common, we are left with x plus 4 upon 3 plus constant of integration as 2 is cancelled. So what is the function f(x)? It is multiplied with root of 2x minus 1, that is my function f(x) is simply x plus 4 divided by 3. So correct answer is option number 2. So I am sure this question is clear to you all. Let's move on to the next one, that is question number 7.